I'm gonna start recording. Um, and that's it from me. Miss Gomez will take over. I did make you co-host, right?
Yes.
Yes. Haha, I didn't forget. And if you guys have any questions on the extra credit, the mosaic puzzle, please put that in chat and I will help you guys out. Okay? But other than that, pay attention, guys, and good luck.
All right. So hello, everyone. Let me go ahead and start sharing. There we go. So we are going to be reviewing your homework 6, Finding Slope Pixel Art. Let me get the link for you guys. I'll drop it in the chat for you. So if slope is something that has been giving you a hard time these past couple of days, then, this is more, think of this as more of a review session. It's to really support you guys more and determine what it is that you're struggling with and helping you guys work through some of these problems by giving you examples. So I'll work through 3 examples. I'm going to show you which ones they are. So go ahead and open up that assignment. There we go. If you scroll all the way down, if you're in Google Classroom, you want to click on Copy of Finding Slope, the pixel art. Oh, get my chat situated over here. There we go. So this is what it looks like. If for some reason this is giving you a hard time, you also have the option of clicking on the option here that says screenshot. And you can work through the problems here, either screenshot it yourself, work on it with your markup option if you want, or print it out. That's also another way. But what is going to be very helpful is if you do have a piece of paper on the side there and a pencil, anywhere where you can actually write your work for a lot of these tables and for these points down here. The graphs are a little easier to work through by just zooming in or doing that mentally. Some of you are able to do that if you don't have to mark it up, but it does help to have a piece of paper and a pencil with you. So let me go back to the pixel art. Here we go. Let me zoom out. There we go. So looking through these here, I picked a couple of problems that I thought a lot of you might benefit from looking at through a couple examples. But if I work through some of these examples and you find that there's another one that's giving you a really hard time, then let us know in the chat too. As soon as I'm done with these 3 examples, I will go back and work through those examples that you thought you might need help on. So I'm going to show you which ones I've picked. Here I have problem 6, problem 10, and problem 19. I picked a graph, and especially this graph, because of what's going on my y-axis here and what's going on my x-axis. I picked this table because you haven't really seen a table that's slanted down, I guess you could think about it, or flat left to right, a horizontal table. You've seen your vertical tables like the examples we worked through yesterday, and I've thought maybe for some reason students might get confused with that one. And then I also picked number 19 to work through with you guys because that's a special type of slope. So we'll work through these, but if there's anything else that's giving you a hard time, make sure to let us know in the chat. We'll help you out as much as we can, but these will be very helpful to listen to. So I'm going to go ahead and get started with number 6. But before I actually do, I need to make sure that you guys are able to access it. So give me a thumbs up if you're good to go. Give me a clap if you need more time to get into your homework. Thank you, Narciso. Melanie, thank you. Okay, I'll give you some more time to get that opened up. But if you gave me a clap, make sure you give me a thumbs up as soon as you're good to go. Yesterday wasn't a cloudy day, right? It was pretty sunny. I can't
I
remember.
think so. Was it sunny yesterday?
It's really cloudy today when I went out there.
Yeah, it is cloudy today. I think
So,
it's because of all the wind and all that stuff.
yeah. All right. Give me a clap if you still need more time. Otherwise, I'm going to go ahead and get started on number 6. All right. So, finding slope. We've talked about the 3 different well, 2 methods, but there's 3 different representations where we can find slope. This here is a graph. So anytime you're working with graphs, I would suggest using rise over run. So our rise over run method. So I'm going to type it out here for you guys. Rise was determining how many units do we go up or down to get from one point to another. So you want to ask yourself, do I need to go up or down to go from one point to another? That would be your rise. And then you want to find your run, which is, do I have to go left or right to go from one point to another? We had color coded these for you guys just to make sure that, I think it makes it easier to remember and tell the difference between the 2 steps that we have to take. Do you have to color code them? No, you don't have to. You just want to remember that if we ever go in the upwards direction, that is a positive number. If we're ever going down, that is a negative number. If we're ever moving left, going to the left on your number line, that's where your negative numbers are. So that is a negative number. If we're moving to the right, you want to write that as a positive number. So using rise over run when you have a graph is a pretty simple way to find your slope. So remember, our rise is looking at our y's when we were subtracting our y's. Our run is looking at our x's when we were subtracting our x's. So you still want to keep that in mind. So when you're looking at this table, one thing you should be noticing right away, especially on my y side over here for my rise, is that I'm going from 0 here. Your number line is skip counting by a certain number. We go from 10 to 20 to 30 to 40. So anytime we're going to find our rise, we're making jumps here, but you want to know how much your jumps are actually measuring. So we're no longer skip counting by 1. Every time you make a jump, it's actually skip counting by a different number. So your y's here, when I look at all those y's on my y-axis, they're going up by 10. So your y's are going up by 10. 10 plus 10 is 20. 20 plus 10 is 30. 30 plus 10 is 40. So we see all of these making jumps of 10. So when you're trying to find your rise, you want to keep that in mind. So before we actually do that, you have to pick 2 points on this line. Remember, when you're ever finding a point, points are those perfect corners of your squares. So what I mean by that is, if you look at these squares here, all of these here have little perfect corners. So all of these, we could easily write a point, a coordinate, in order to pair 2. If I go in here and I say, well, no, this is a point. Yes, it is a point, but all of a sudden, we're in between numbers and we could either get into decimals, and using decimals won't help you when you're writing rise over run. So when we're looking at this line here, you want to find perfect corners in those lines where you have a perfect point that we can easily find. So I'm going to delete these. Those were just examples. I'm going to find 2 points on this line. When I follow this line from the left to the right, here's a perfect corner. And as I move up, here's another perfect corner. So sometimes that's even the most important step is being able to find your points on the line. So now that I have 2 points on this line, I'm going to go ahead and I can even label them to make sure I keep this in mind. I always read my graphs from left to right, so I'm going to label this as point 1, and that's going to be my second point. This helps me think of, okay, if I want directions of how to go from point 1 to point 2, I need to rise up or down to get to it, and then run left or right to get to that point 2. So I keep in mind the order that I'm going in. So we'll start off by using our rise from this point here. Do I have to go up or do I have to go down to get to point 2? If I go down, I'm getting further away from it. So in this case, I'm going to go up and I have to make a jump. I jump over 1 time. So making a jump, 1 jump here, is not worth 1. It's actually a jump of 10 units at once. So why is that? Because we're going up by 10. So making this jump once means I'm going up by 10. So I just found my rise. That is a positive 10. So now that I found my rise, if I'm at point 1, to get to point 2, I have to jump up 1 time. That gives me 10. Now I want to run. So I can either run to the left, so this way is my left, or I can run to the right to get to point 2. If I run to the left, I'm not going to go to get to point 2, so I have to run to the right. Now, before I do that, I have to think about how much each jump is going to be worth here in my scale. When I look at my x-axis, these numbers here, 10 to 20 to 30 to 40 to 50, are not skip counting by ones either. These x values, my x's, are also skip counting by tens. So if my x's are going up by tens, anytime I make a jump, I need to remind myself that I'm making a jump that is worth 10 units. So when I do that, I should count by tens and I go 10, 20, 30. So remember, each one here was 10. So this will be 20 and this will be 30. So my run here is 30. And I'm going to the right side, so it's a positive 30. So a rise over run. Think of them as directions. Think about this as this being your house and you want to get to Starbucks. What are the directions you have to take to get to Starbucks? I have to go up 1, but that is 10 units. And then I have to jump over 10, 20, 30 units. And then you're at Starbucks. I think that's what we mean by directions. Okay, so now that you have your fraction, you always want to ask yourself, do I need to simplify this fraction? In this case, I can see I have a 10 and a 30. Both of these numbers are even, so most likely yes. And I tried dividing by 2, but it's such a small number I'm dividing by, so my fraction is not going to be fully simplified. I could try to find a number that I can divide both of these by, a common factor. And since these end in 0, I can divide both of these by 10. So now I have 10 divided by 10, which is 1, over 30 divided by 10, that's just 3. So this is our final slope. And some of you might think, well, isn't that just what's happening here? I just went up 1 and then I went 1, 2, 3 over. So why couldn't I just write 1 over 3? In this case, it works out nicely because we're skip counting by 2. But in your homework assignment, there are some scales that are skip counting by, we're skip counting by 10 here, but there are other scales that you're skip counting by 2s, maybe by 5s, maybe by 4s. So you want to pay attention to those scales. And actually, this is a big in for some of our future tests that might come up in the way future, in like months. But you are going to get problems like these. So this is something you want to get used to. Okay, so when you go into your homework and you are going to type in your answer, you want to type in m equals 1/3. When you type in that answer, it should turn black, and you can press enter and it'll turn it black. If it turns red, then that means we did something wrong. We typed it in wrong. So if I go over to question number 6, double click on that bar there. If I put m equals 1/3, notice it's red right now, but if I press my enter or if I click out of it, there we go. Very slow this time. If I press enter and I click out of it or just click somewhere else, it turns black, and then you notice a bunch of colors started to show up. The little squares were filling up with colors. That's how you know it's correct. If you're getting a red answer here, it's wrong. So when you have a graph, you need to find rise over run, count the units you go up, count the units you go over. So again, at the end of this, after I go over these 3 examples, I'll let you take screenshots of all of these. Use these as examples to help you out on when you're doing it on your own. Yeah, of course. Yes, of course. You have that option of doing it on paper. It just means that we're not going to see your answers probably filled in. But if you take a screenshot of that, you can also turn it into Google Classroom. So we want to see the work. If you're doing it on paper, we want to see that work.
Or text me or email me, whatever it takes to get it to me. That's all that I care about.
Yeah, if that's easier, text it, email it. But yes, you can. Okay, so give me a thumbs up if you're okay with this problem. Give me a clap if you need any type of explanation here, or if you need more time, if you were writing it down. But if you're good to move on to the next example, you're welcome. If you're good to move on to the next example, give me a thumbs up. Thank you. All right. So I'm going to show you how to work through example question number 10. So when you look at all these tables, they're just like yesterday's tables. They're nice going up and down, but I knew that for some reason, some students were going to look at this table and ask themselves, wait, how do I do that? Why does it look this way? So I picked number 10 for that reason. So when I look at number 10, I still have ordered pairs. Think about your other tables when they were vertical tables here. Your X and your Y, whatever number we had here, was a pair with the number right next to it. So these were a pair. We still have pairs in this table, but instead look at your X and look at your Y. One's on the top, one is on the bottom. So the top number is a pair with the number on the bottom. So in this case, 1 and 1 is a pair. 5 and 17 is a pair. 9 and 33 is a pair. And 13 and 49 is also a pair. So this is how you would pick your pairs. What I noticed in some of your your turns, some of you decided to take 5 and then pair it up with, I don't know, let's say 49. You're mixing and matching here. That's not making pairs. You're taking the pairs apart actually. So you don't want to do that. So when you pick your pairs, make sure they are either right next to each other here like this, or one's on the top and one's on the bottom when you have this type of table. So be careful with that. Okay, so other than that, I'm going to show you how do we work through finding the slope when we have a table. When we have a table, you are going to want to use your slope formula. And if you've forgotten your slope formula, that's fine. I'm going to write it down here. We need to subtract our y, so our second y minus our first y. all over our second x minus our first x. So I'm going to color code these still for you guys. Do you have to? No, it's just, I find it that a lot of you are remembering how to do these or where the placement is because you see the colors, you think red, oh, my y's, subtract my y's. Then you're thinking of the bottom. Oh, that was green, so I know I'm going to subtract my x's. So that is your formula. We use this formula to find the slope of a table, which means you need two ordered pairs. So you can go in here and you can pick any two ordered pairs that you want as long as you keep the pair together. But I am going to go ahead and pick my first pair here. And the reason behind that is because they're just ones. And I know this equation here or this formula has me subtract numbers, and I would rather subtract by ones than subtract by really big numbers. This is a 49 and that's a 13. Do I want to start working with 49 and subtracting from 49 or subtracting 49 from a number? No, I don't want to, so I won't pick those. You can pick whatever you want though. So that's going to be my first pair. So when I'm working with this pair, I want to label this one as x1 and y1, since that is my first x coordinate and my first y coordinate. See how they are paired up. The next pair I'm going to go with is this one here, 517. Why am I picking 517? Again, I don't want to work with really big numbers. I don't want to work with any of these here. So I'm going to avoid those. Does it always have to be the first two? No. Okay, so now that I picked my second point, then I can label that as x2 and y2. The numbers are top are my x coordinates and my numbers on the bottom are my y coordinates. So keep that in mind. Okay, so you picked your points, you labeled them, and now you're ready to use your formula. So before you actually put your values in there, I need you guys to do me a favor and start by writing that bar in the middle, your fraction bar, and see these subtraction symbols here in the center. Write those down. It's so helpful to keep those in the center here so that when you write your numbers in, you'll see sometimes we have double negatives. And sometimes when our numbers down here have negatives, some students forget those negatives and think that this negative is the exact same thing as that negative. And that's not the case, so be careful with that. All right, so I'm going to get your guys' help here. I want you guys to help me out fill in my formula. And you can either unmute yourself or you can let me know in the chat. But the first number I need to have here is my second y. What number did I pick for my second y? What is y2? So look at this one here. Y2 should be in the front. Which one here is Y2? Yes, thank you. 17. So this is Y2, so I write 17 in the front. In the back here, I need to have Y1, so the first Y. So what number is my first Y? One, yes. So you want to write 1 at the very end there. And now you go to your denominator to the bottom and you repeat, but with at your x's. So x2, what number did I choose for x2? Yes, 5. And what number is my first x? What number did I choose for x1? 1. And that's it. That's how you complete your slope formula. And now all you have to do is your subtraction sentences, the one on the top and the one on the bottom. So we have 16 minus 1. 16 take away 1. I'm already saying the answer. I meant 17 take away 1. My brain is always thinking ahead.
I love it whenever I do stuff like that. It's just so hilarious.
All right, so 17 minus 1 is 16. If some of you caught on to that. And now on the bottom, we have 5 take away 1. 5 minus 1 is 4. So at this point, we have a fraction, which is what our slope should be. But you want to ask yourself if you can still simplify this fraction. So 16 over 4. I see the bigger numbers on top. So in this case, I might want to see if my top number can be divided by my bottom number, if the numerator can be divided by the denominator. Why can we do that? Because a fraction is also showing us division. It's a rate, it's a ratio. So we can take that and say 16 divided by 4. 16 divided by 4 is just 4, which means our slope here is a 4, a positive 4. And so we'll go on over to our worksheet and we'll want to type in m equals 4. If it turns black, then we know we did it correctly. If it stays red, then it might be tripping out a little bit because we know we did it right. But let's take a look. There we go. So m equals 4. So that would be for number 10. Yes, of course. There you go. So what's nice about the formula is that you already have a layout of what it is that you're supposed to do. You just want to make sure you put your numbers in the correct spot. To put your numbers in the correct spot, you want to make sure you keep your pairs together. Don't mix and match, meaning don't jump from one to another. You don't want to do that. You're welcome. Again, I'm going to let you take a screenshot of everything. Right now, I've given you an example of a graph. I've given you an example of a table. And the next one we're going to work through is points. What do we do when we have points? But I know some of you are writing this down. So give me a thumbs up if you're ready to move on to the next question. Give me a clap if you need a little more time here. You guys are either really busy with your worksheet or you're asleep.
I've had a couple of kids send me messages on theirs, but mostly on the extra credit.
Okay. All right, we're going to go ahead and move on over to number 19. So number 19 is way down here in the bottom. This is where you have all of your points. So for these questions here, you're going to want to use this method. Unless you want to graph the points and then find the slope by using rise over run, you can do that too. You have options, so you don't have to do it this way. You could have put this in a graph if you want to. But I wouldn't because it has the really big numbers, but it's up to you. We're going to look at number 19 here. We have points. So how do we work through a question that is giving us points? For a problem that's giving you points, you also want to use the slope formula. Do you have to use the slope formula? No, but you can graph them if you prefer, and then find rise over run. But I don't have graph paper with me, and I don't have a coordinate plane where I can plot these, so I'm just gonna use the slope formula. So I want to remember that my slope formula is where I have to subtract my y's on the top. So the second y minus the first y divided by the second x over, sorry, minus the first x. So always start off by writing your formula down. I find that it's really helpful if I just have it there as a reference. So after I've written down my formula, I want to go in here and label my points. So I need to decide which one's my first point, which was my second point. I think pretty simply here. If I see this one here in the front, then I'm just going to say that's my first point. So I'll say this is X, the first X and the first Y. So I go in there and label them. And for the second point, I will do the same, label this as my second X and my second Y. So X2, Y2. So give me a thumbs up if you're okay with that step. Labeling just points X1, Y1, X2, Y2. Thank you, Ashley. All right, so now that you have these labels, you can go ahead and actually use your formula and plug them in, replace them into your formula. But I will always start with the bar, my fraction bar, and my subtraction on the top and on the bottom. This is an example of when it is really helpful to write your subtraction symbol on the top and the bottom first. So you want to pay attention to this one. All right, now that I have my coordinates labeled, I want to plug in my numbers, and I'll start by plugging in Y2, my second Y. My second Y was 7, so that should go in the front. And then your first Y goes in the back of that subtraction symbol. My first Y here is 1. And then I will do the exact same process with my X's. The second X goes at the very front. My second X I said is -5. So I'll write down -5 here. And my first X goes in the back of that. And my first X was -5. So this is where you want to be careful. Remember, this negative here is part of your formula, but this X1 also has a negative. So I need to make sure that before I write that 5, I also include that negative. So I will have a negative here and the 5. That is what we want to make sure you don't make a mistake on. Some students will just say, oh, this is just -5 minus 5. This will not be the same thing as this. So you have to be careful with your double negatives. You have to write your negative before you actually write in your numbers in there. Okay, so now that we have that, I also want to point out that when you have a double negative here, it turns into addition. A subtraction and a negative, that turns into addition. Now, normally we can just go in here and write it on top like that. But because I want you to have your notes, I want you to see your notes, I'm going to leave it highlighted and I'm just going to write it down below. A double negative means I'm adding. So this is -5 plus 5. So keep that in mind. A double negative, you need to turn that into addition. So after getting that out, we can go ahead and just do our subtraction on the top and our subtraction on the bottom. 7 minus 1, that is 6. A -5 plus a 5, these are different signs. When you have different signs, you subtract the numbers. So that just gives us 0. So I gave you one really good example here in the points. It's when we get these double negatives, which we need to turn into addition, and when we have a 0 in our denominator. So this is your special type of, a different type of slope. It's not positive. It's not a negative slope. This is our undefined slope. So a 0 in the bottom, a 0 in our denominator means we have an undefined slope. So keep that in mind, 0, undefined. Why is it undefined? Again, that's just because a 6 divided by a 0, there's no way we can think of 0 times some number that's going to equal 6. That's impossible, which is why we say undefined. So keep those in mind. So when we go into our worksheet and we type in our answer, we should be typing in M equals undefined. When you press enter, it should turn black. So let's go take a look and see. That was question number 19. You still want to type in M, your equal sign, and then undefined. And that turned black, so we know that is correct. And I'm going to zoom out so that you guys can see all of my answers here. 1, 2, 3, yeah, 3. So we worked on 6 together, number 10 together, and number 19 together. So you should have these 3 in your worksheet. But what is really important is that you at least have the work to help you out with the other problems. So I'm going to go ahead and zoom out. I recommend that you take a screenshot of this now so that when you're working through a graph and that when you're working through a table, you use this as notes to help you work through the other ones. They're exactly the same, but different numbers. Notice here, our line is going up, so our slope is positive. But if you have a line going down, that should remind you that's not a positive slope, that's a negative slope. So make sure you look out for your answers there. And I'm going to go ahead and go down for those of you that want to take a picture of your points example. So go ahead and take a screenshot of that now. Okay. So at this point, you have options. You can either choose to stay here with us and continue working on your pixel art homework. So it is a homework assignment, which means you're doing it in class too. So we're giving you that extra help if you need any. But if you think you got this and you can do it on your own, then you're more than welcome to go ahead and leave, but complete your exit ticket. Or you can stay here on Zoom. If you have questions at this point, I can go ahead and work through more examples. If you have a question on any of the problems over here, pick one. I can work through another example and help you guys out with it. But if you think these examples really helped you out and that you are confident in working through these on your own, then you can try working on them on your own. And you can even stay here on Zoom with us. And we can, if you have any questions, you can let us know in the chat. We'll help you out through the chat. But anybody want to go through another example? Let me know in the chat, or you can unmute yourself.